Hi, in this video, we will derive the formula for the area of a right triangle ABC. There it is. We will be using the area assumptions that we discussed in another video. We will also use a theorem that we discussed in another video, which states that the area of a rectangle is the product of the length and its width. So let us proceed as follows. I have a cardboard cutout of this right triangle. In fact, that's what I used to draw the right triangle. Since I know the area of a rectangle's formula, I'm going to create a rectangle in this manner. So let's read how we create a rectangle from the right triangle. Find the midpoint M of AC. This is AC and this is M. Rotate triangle ABC about M by 180 degrees so that A and C have swapped positions. The points A and C have swapped positions, and this point B gets to a new point which we're going to call D. It will be easiest for you to see this if I put back this cardboard cutout. And I now fix this point M and I rotate this 180 degrees until A and C get swapped in that manner. And this point B now got to move to a new point, which I'll call D. So let me complete this rectangle the best I can. Okay, there it is. Okay, so we have completed step number 2. And you heard me say ABCD is a rectangle. Wait a minute, let's convince ourselves indeed ABCD is a rectangle. And to do so, I simply need to show you that every angle that you see here is a right angle. This angle is of course a right angle. This angle is also a right angle if you think about it, about the rotation that we did. Here's the rotation. When we rotated about the midpoint, 180 degrees. Notice this angle ended up with, right here became this angle. So if this is 90 degrees, that's also 90 degrees. How about this angle? Why is this angle 90 degrees and why is this angle 90 degrees? For that, let's proceed as follows. Let me mark this angle in this manner, and this angle, I'll make a mark like that. Recall a theorem about triangles. The sum of the degrees of the 3 angles in a triangle is 180 degrees. In this right triangle, we know this angle measures 90 degrees. That means the sum of the degrees of these 2 angles must be 90 degrees. Now notice this angle is also same as this angle because of the way we carried out a rotation. So let me put the cardboard cutout back so you can see this angle. In fact, when I rotated the triangle, ended up becoming exactly this angle. So if the sum of these two, if the sum of the degrees of these 2 angles is 90 degrees, since these 2 angles measure the same, we can say the sum of the degrees of these 2 angles is 90 degrees. So that means this angle is 90 degrees. Same way, this angle is 90 degrees. So we can be sure that this figure ABCD is indeed a rectangle. And now let us move on and find the area formula for the triangle ABC. So let us do that now. Here's a quick reminder of area assumptions number 2 and number 4. Number 2 says that congruent figures have the same area. So here that number 2 is relevant because notice triangle ABC and triangle ADC, they are congruent. Why is that? Think about the way we performed our rotation. If you rotate this triangle about M 180 degrees to lie exactly on top of ABC. That's how we created ADC. So triangle ABC and triangle ADC are congruent. So remember that these 2 triangles are going to have the same area by assumption number 2. Assumption number 4 tells you if a big region is partitioned into many non-overlapping smaller regions, then the area of the big region is the sum of the areas of the smaller regions. Here that's relevant because our big region is ABCD. So what we have is area of the big region ABCD. We are saying by area assumption number 4 that area is really equal to the sum of the areas of the smaller regions. The smaller regions here are this triangle, so this area of triangle ABC, plus this triangle, which is the area of triangle ADC. So we can write this first statement using assumption number 4. So this is a number, and that number is equal to sum of these two numbers. Area of triangle ABC is a number, area of triangle ADC is also a number. Now we are saying the sum of those two numbers is equal to, let's see what we have here. Area of triangle ABC, I just rewrote that, area of triangle ABC, plus. Now instead of having area of triangle ADC in this expression, I'm changing that to area of triangle ABC. I can do that because area of triangle ADC is exactly equal to the area of triangle ABC. So this number will exactly equal this number. I'm adding two numbers here. I'm adding two numbers here. This number is exactly same as this number. This number, by our argument, is exactly same as this number. Area of triangle ADC is exactly area of triangle ABC. So that's why I can put that equality sign. Now we put another equality sign and see if we can simplify this expression. We are adding two numbers that are exactly the same, area of triangle ABC and area of triangle ABC. So now we know that we can write that as 2 times area of triangle ABC. So what we have now is area of ABCD is exactly equal to 2 times area of triangle ABC. So let's go over to the other board and continue this discussion. So here's what we had on the other board. 2 times the area of triangle ABC equals the area of the rectangle ABCD, and this is the picture that we had. Now in this equation, we can divide both sides of the equation by 2. Take the time to do that in a separate step in this manner. And from here we can see on the left hand side we get area of triangle ABC, and on the right hand side we get half of area of rectangle ABCD. So what we are saying is area of triangle ABC is 1/2 of the area of the rectangle ABCD. Now as I said before, we have a theorem that we have done which says that the area of a rectangle is the length times the width. So here the area of this rectangle is length of this side, which is in this notation BC, and these vertical bars that denotes the length of the segment BC. Similarly, multiplied by the length of this segment, which we can write it like this. Here you can either put a multiplication sign or a dot like that. And sometimes we refer to this as the base of this triangle. So that's what I have here. And this length, this, sometimes we refer to as height of the triangle. So what we have here is area of the triangle ABC is 1/2 times the base times the height. So that is the formula for the area of a right triangle. Sometimes for a right triangle, we also call these sides, these two sides that are around this right angle, we call them the legs of the right triangle. So this is a leg of the right triangle and this is a leg of the right triangle ABC. So we may say that the area of triangle ABC is 1/2 the product of the length of the two legs that flank this right triangle. You can also remember it that way. So in the next video, we will look at just any triangle, not just right triangle, and we will derive the formula for the area of such a general triangle. Thank you.